This is a LetCode 239, which is a hard problem. It's a sliding window maximum. So basically in this question, we get an array and we get some k, let's say k is 3, and whenever we move a sliding window, we need to tell what is the maximum. So first we have the maximum of 3, then we have again the maximum in this sliding window is 3, and then the maximum now is 5. So on its surface, it looks simple, like in every sliding window, let's have a left and a right, and in every sliding window, let's scan the part. We can do this because, it can be often say that k is large, and even if it's not large. So basically, I'll drop a bomb here because what we need to actually do in order to save this, to solve this problem very elegantly, is to be aware of the monotonically decreasing stack, basically monotonic stack or monotonic decreasing or increasing stack. So basically we are going to have a data structure, right? And we are going to add numbers with some rule. If we have, we need to decide when to remove numbers, when to add numbers to the stack. And this is going to be the queue, so we can also remove from the head. And when we need to remove, let's take a look at these 3 decisions. If we have a new number and the stack is empty, let's add it. Okay, so we add this number to the stack. If the next number is big, then we don't have any use anymore of this because the windows will only increase to the right. So this we don't need anymore. We can remove it completely from the left because this is increasing. Once we have a number that is smaller, the next one, then we need to make sure that this is a monotonically decreasing stack. Is it monotonically decreasing? Yes, -1 is less than 3. And now we have -3, and we can edit, still monotonically decreasing. And now we have 5. Once we have 5, we can get rid of all of those. We won't need them at all. And let's say that we had, 3, 1, and now 2 is coming. What do? We can get rid of all the smaller numbers and just add this one. Now, you see, we would always have in the sliding window, in this monotonically decreasing start, on the left side of the stack, we would have the largest number, and on the right side, the smaller, because this is monotonically decreasing stack. And also, we are not going to save the actual numbers. We are going to save the indexes because we need to know also when to empty the stack if the amount of indexes has increased, that it's beyond the window. The solution looks much simpler, but basically you need to learn the monotonically decreasing, the increasing stack, and take a decision on these 3 occasions. And with that, let's move directly to the answer. Okay, so this is the answer. We first initialize the queue. Right, so we first initialize the queue, which means we can pop from the left, from the right. So we have this variable, the queue, and in the answer, we need to return a new array, which will represent all the maximum of the current window. Then in our current pattern, we scan all the numbers. So here we scan all the numbers. This is almost always in all LetCode question. You need to have an outer loop that scans all the numbers. And once we scanned all the numbers, we need to take 3 decisions. Decision number 1, when to pop items from the right. The cleaner decision number 2, it's not a decision. We would always need to add the current index to the queue because it can always be the maximum one once the window size has moved, and let's say this is the maximum. So we always need to add the current index. And then we need to decide when to pop from the left. So we pop from the right if we received a new number which is larger. If we received a new number in an array which is now larger, we don't need all of this. This can be the maximum of this, and we won't even never need to touch the left ones. They are not relevant anymore. So once we receive a new number, we just immediately remove all the smaller numbers from the stack, and we append it always. And then we check if we pass the window size. If we pass the window size, And we know this is why we store the indexes. The window size currently is the first number represents the oldest index in the window size, I old. And we are currently at I, so we do this computation, add 1 for the window. So we pop from the left, and now we can check if we are having a valid window, because in the beginning we could have traversed only 2 numbers. So if we now have, let's say k is 3, if we now have a valid window size, right, then we just append the left number. We don't need to do any max or something, because this is going to be a monotonically decreasing queue. So always the left first number is the maximum one. So we just add the maximum one. And then when we finish this, we return the answer. Again, scan all the numbers, remove from the right if the current number is larger, because this is monotonically decreasing the queue. Always add the current number, because it can always be the maximum. Decide if to pop from the left if we broke the window size limit. And then, if we had a valid window, we won't have a valid window at the beginning of the array, then add the left one. Why the left one? Because it's always the maximum, monotonically decreasing stack. So this was max sliding window question. Hard.